This is the Algebra 1 credit recovery for Unit 12. 1 asks, what are the roots of the function h? So taking a look at our graph of function h, we know that our roots are the same things as the x-intercepts. Okay, so here I'm going to see where my graph crosses the x-axis. We see that we have that in two places. One is where x is equal to -5, and the other one is where x is equal to 1. So here we get x is equal to -5 and 1. Number 2 says, which of the following represents the solutions of the equation x squared minus 3x plus 1 is equal to 0? So in order to solve this, if we take a look at each of our answer choices, they're all set up using the quadratic formula. So that's what we're going to need to use here. In order to do that, we need to figure out what a, b, and c are equal to. Those are just the numbers in front of our variables in our quadratic equation here. So here, the hidden number in front of x squared is my a, which is 1. B is the number in front of x. We see that it's -3. And c is my last number, which is just 1. So to plug it into the quadratic formula, we know x is equal to -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So now I'm just going to plug in those numbers I know. I'm plugging in -3 for b, 1 for a, and 1 for c. When I solve it out, I know a negative times a negative should give me a positive, so this ends up being +3 in front. If I look at each of my answer choices, I can already eliminate a and b because they have -3 in front. From here, I would plug all of this into the calculator just like I see it, everything underneath the square root sign, including my parentheses, and I should get +5, and on the bottom 2 times 1 gives me a +2. So this one ends up being D. On these next few problems, it says you can use any method you want to solve these quadratic equations. So taking a look at number 3, first we need to check to make sure it's in standard form, meaning that everything is set equal to 0, and I have my x squared, then x, then my number. From here, we can go ahead and plug it into y equals and solve for our x-intercepts. So I went ahead and plugged it into y equals. Remember, your x button is right here. Taking a look at my graph here, if you go ahead and graph it in your calculator, if it looks a little funky, all you have to do is hit zoom 6, and it should graph it for you. It looks like we crossed the x-axis in 2 different places. In order to find them, we hit second trace, 2. I'm going to get my blinky spider on top of one of those x-intercepts. I'll do the left one first. Once it's as close to that x-intercept as possible, I hit the left button 3 times, 1, 2, 3, enter. Right button 6 times, 1, 2, 3, 4, 5, 6. Hit enter, and hit enter one more time. From here we get x is equal to -5. If I do it again, second trace 2. Okay, we get onto the other x-intercept. From here I hit the left button 3 times, 1, 2, 3, hit enter. Right button 6, 1, 2, 3, 4, 5, 6. Enter, hit enter one more time. We get x is equal to -3. So on this first one, my two solutions are x is equal to -5 and -3. Number 4, again, we need to first check if this is in standard form. This one is not because our equation is not set equal to 0. In order to set it equal to 0, I need to get rid of that 35. Since it's a +35, I'm going to end up subtracting 35 from each side to get rid of it. We're left with x squared minus 2x minus 35 is equal to 0. From here, you can just plug it into y equals just like you see it, and hit second trace 2 again to find both of those x-intercepts, because here you should end up with 2 again, okay? And on this one, you should end up with 1 where x is equal to -5 and x is equal to +7. Number 5, this one is a little bit different. Again, we need to make sure this is in standard form. Is everything set equal to 0? No, we need to move our 11x over. Since it's positive 11x, we're going to subtract 11x from each side. When I rewrite this out, I'm going to go ahead and write it as x squared minus 11x minus 12 is equal to 0, because I want my x squared term first, then my x, then my number. From here, we can go ahead and plug this into y equals and solve for our two solutions. Okay, so taking a look at this one, we're going to plug it in. Going back to y equals, we get x squared minus 11x minus 12. So going to my graph, I see only one of my solutions. Since this graph goes down like that, I know it's going to end up coming back up. So let's go ahead and zoom out here. You hit zoom 3, hit enter, so you can see your whole graph. Okay, it looks like I do have two x-intercepts, so I'm going to hit second trace 2. Get that blinky spider as close to it as possible. Hit the left button 3 times, 1, 2, 3. Enter right button 6 times, 1, 2, 3, 4, 5, 6. Hit enter and enter one more time. X is at -1. I do it again. Get my blinky spider to that other x-intercept. Hit the left button 3 times, 1, 2, 3. Enter. Right button 6 times, 1, 2, 3, 4, 5, 6. Enter. Hit enter one more time. The other one is at x is equal to 12. Okay, so from here, going back to my answers, we get x is equal to -1, 12. Number 6, on this one, everything is set equal to 0. So I'm going to go ahead and plug this into y equals just like I see it and get my two x-intercepts. So from here, y equals, we have 2x squared minus 3x minus 10. If I go to my graph, if it looks a little funky here, we hit zoom 6 to get it back to the normal graph. Oops, zoom 6. And from here I can find my two x-intercepts. I'm going to hit second trace 2, get that blinky spider over, hit the left button 3 times, enter, right button 6, enter, and enter one more time. Let's round this one to -1.608, so to 3 decimal places. I'll do it again, second trace 2, get that blinky spider over to the right side, hit the left button 3 times, 1, 2, 3, enter, right button 6, 1, 2, 3, 4, 5, 6, enter, enter. This one rounds to 3.108. So my two solutions are x is equal to -1.608 and 3.108. Number 7. On this one, again, I'm going to just plug this into y equals. We're going to figure out what b is equal to. So when I plug it into y equals, I have 4x squared plus 8x plus 3. Go to my graph. From here, I do have two x-intercepts. Let's go ahead and zoom in to see if I can see this graph a little bit more easily. I hit zoom 2 to zoom in and hit enter. So it looks like I have two x-intercepts there. Again, we do second trace 2. Get my blinky spider over to one of them. I always do my left one first just because, but you could do the right one. Hit the left button 3 times, 1, 2, 3. Enter, right button 6 times, 1, 2, 3, 4, 5, 6. Enter, hit enter one more time. X is equal to -1.5. If I do that again, you go over to the other x-intercepts. Left button 1, 2, 3. 1, 2, 3, 4, 5, 6. Our other x-intercept is that x is equal to -0.5. So on this one, b was -1.5 and -0.5. Number 8. Again, this one we can just plug it into y equals. From here, you should be able to find your two x-intercepts. We're going to round it 3 decimal places again since it wasn't an even whole number. We would have gotten n is equal to -1.574 and 1.130. Number 9, on this one, in order to plug it into y equals, remember we need everything onto one side. Okay, so here it doesn't matter what you move, whether it's a 9n squared or the 4 and the plus 7n. But here I'm just going to move everything over from my 9n squared, so I'm just going to move one thing. Instead of positive 9n squared, I'm going to subtract a 9n squared from each side. So when I rewrite that out, we get 0 is equal to negative 9n squared plus 7n plus 4. And from here, we can still plug that all into y equals. When you do that, you should end up with 2 x-intercepts again. Again, it's not going to be whole numbers, so we're going to round that to negative 0.383 and 1.161. Our last problem, number 10. On this one, since it's all set equal to 0, we're going to plug it into y equals. Okay, so let's do this one together. Go to y equals. We have x squared minus 4x plus 4. Go to my graph. Okay, and here, since I still am zoomed in, I'm going to go ahead and bring it to my normal screen. So I hit zoom 6. And from here, it looks like it only touches my x-axis once, but I can still go ahead and find it. Okay, since here it looks like it touches at this number right here, I can also go ahead and check my table to see what number does my graph touch the x-axis at. In order for it to touch the x-axis, remember an x-intercept is where the y is equal to 0. So from here, I can go to my table by hitting second graph. And from here, where do I see y is equal to 0? When x is 2. Okay, and if I go on my graph, there's no other point in y where y is equal to 0. And that also matches my graph here. When x is 2, that's the only point in which my graph touches my x-axis. So on this one, we only get one solution, and that is when x is equal to positive 2. And that is the